Welcome to the lecture on Preprocessing Part 1. Part of the material presented in this lecture is taken from the following book, while transcription and interpretation errors are responsibility of the lecturer. This lecture introduces the following concepts: aggregation and sampling, with specific reference to random sampling with and without replacement, and to stratified sampling. Preprocessing or data preprocessing is a broad area and consists of a number of different strategies and techniques that are interrelated in complex ways. Preprocessing is devoted to make the data more suitable for data mining. Preprocessing topics are the following: aggregation, sampling, dimensionality reduction, feature subset selection, feature creation, discretization and binarization, and finally variable transformation. We start by introducing the concept of aggregation. Aggregation consists of combining two or more records into a single object. To show how aggregation works, we exploit the following portion of the customer scores database. We also assume that you suspect that the day calls, so the value of the day means attribute, depends on the state where the customer lives, so it depends on the value of the state attribute. Then you want to check how day means values change across state values. So you make the decision to aggregate records on the basis of the value of the state attribute, and you only focus on state and day means attributes while not preprocessing the others. However, you are left with the following question: how to aggregate the values of the day means attribute? First of all, you notice that the fourth record is missing the value of the state attribute, and so you make the decision to apply the record removal strategy, which brings to remove the fourth record from the available portion of the customer scores database. Then the day means is a quantitative attribute, and typically such an attribute type is managed by computing the sum or the average when aggregating records. To show how to aggregate the value of the attribute day means in the case where we use the information concerning the state attribute, so a nominal attribute, we proceed as follows. Let us show how to aggregate the values of day means when the value of the state attribute is equal to ks. So we simply find all the records where the state attribute is equal to ks. These are the first, the sixth and the ninth, and we simply do the same for the day means attribute. Then we can proceed in two different ways. We can compute the average value of these records, so 265,1 plus this value divided by 3, or we can compute the sum of the values of the first, sixth and ninth record of the day means attribute. However, you can ask yourself the following question: how to manage qualitative attributes such as churn? To answer the previous question, we have two different options. The first one is to omit the considered attribute, so to omit the churn attribute. The second one consists of summarizing the values of the churn attribute as the set of all values it takes for any given value of the aggregating attribute, that in our case is the state attribute. Also in the case of the nominal attribute and in particular of the binary attribute churn, we make the decision to show how the aggregation works when the aggregating attribute is the state attribute. And also in this case we show how the aggregation for the churn attribute works in the case where the value of the state attribute is equal to ks. So we proceed as follows. We find all the records where the value of the state attribute is equal to ks, so the first, the sixth and the ninth. We make exactly the same for the churn attribute, and we point out that the first record has a missing value, so it will be discarded. So the two valid records for the value ks of the state attribute are the sixth and the ninth. In the sixth, the churn attribute takes the value y, while in the ninth observation the churn attribute takes the value n. So the aggregation will result into this pair y and n. In data mining, the aggregation operation is extremely important. The main advantages of aggregation are the following. First, we usually obtain smaller data sets, so we need less memory and processing time, and thus more time-consuming data mining algorithms can be used, or the most performing ones. Second, we have a change of scale and scope, and in this case, aggregation provides a high-level view of data instead of low-level view. Finally, the aggregation allows us to achieve a reduced variance. In this case, attributes computed on aggregated records are more stable, they have reduced variance for quantitative attributes and reduced entropy for qualitative attributes than those associated with the native records. This is a statistical effect. A drawback, however, consists of losing interesting details in the data. Aggregating sales volumes from days to weeks lost the information about which day of the week has the highest sales volume. Let us now introduce and describe sampling. Sampling is an extremely relevant tool for data mining, and to show why, we consider the following situation. Your friend, the telecom company CEO, tells you that the customer scores database to analyze contains more than 1 billion records. You know that such a huge amount of records did not allow you to use the most powerful but computationally demanding data mining models and algorithms. And these are those you hope will be the best performing for solving the churn problem. So in such a situation you are left with the following question. To use the less powerful data mining algorithms and models, or to develop a different option? You make the decision to develop a different option. In particular, you made the decision to sample a given number of records from the customer scores database, to sample a number of records which allows you to use computationally demanding data mining algorithms. Those you hope will be the most successful for solving the churn problem. However, in such a setting, you are left with many questions. For example, which observation, which records to sample, which observation to use for learning the data mining algorithms, which are the properties of the sample you will use for learning the data mining algorithm, which are the implications of the sampling on the results you get from the learning process. All the questions we asked before imply that a lot of attention must be paid to sampling. Indeed, the key principle for effective sampling is the following. Using a sample will work almost as well as using the entire dataset if the sample is representative. However, we are left with the following question. When a sample is representative? A sample is said to be representative when it has approximately the same property of interest, as the original set of data, i.e. the original data set. So let us take into account the following situation. Assume that the mean of day means, of the attribute day means, is the property of your interest. Then a sample is representative when day means has approximately the same mean value as the original set of data, so the mean value computed on the overall set of data. In the case of the 10 records of the portion of the customer calls database, we have that this mean value is equal to 179.68. In this case, we make the assumption that the overall dataset is represented just by that 10 records. So we focus now the attention on these 10 records for the attribute day means, and we extract a sample consisting of 5 records, which are shown here. Then we compute the mean value of these 5 records for the day means attribute, and we obtain that this mean value is equal to 257.98, which is quite different from the mean value of the 10 records of the portion of the customer calls database. So in this case we can conclude that this sample is not fully representative of the population of the dataset from which it has been obtained. However, a different sample can be extracted from the 10 records that we assume represents the entire customer calls database. For example, we can extract the following sample consisting of 4 records. Then we use these 4 records to compute the mean value of the day means attribute, which is equal to 180.32. Then we can conclude that this second sample, consisting of 4 records, is more representative than the first sample consisting of 5 records. Indeed, it has a mean value which is close, and it is closer than the mean value of the first sample to the mean of the 10 records that we have considered to be the full customer calls database. Let us now focus the attention on sampling approaches. Before starting, it is important to recognize that we must choose a sampling scheme that guarantees a high probability of getting a representative sample. This involves choosing the appropriate sample size and sampling technique. Many sampling techniques exist in the specialized literature, but only the most basic one will be presented here. We now make the assumption that these 10 pictures are associated with the dataset from which we will sample records. So the first and most basic approach for sampling is known under the name of simple random sampling. In this approach, each record of the dataset has the same probability to be included in the sample. However, the simple random sampling approach splits in 2 different kinds, or it can be of 2 different types. The first one is simple random sampling without replacement, and in this case each selected record is removed from the dataset, so it cannot be sampled more than once. To show how the simple random sampling without replacement approach works, we exploit the following graphical representation. Assume that we have selected these records to be sampled from the dataset, so this record will be extracted from the dataset to form the first element, the first record of the sample. Then we select a new sample and we make the assumption that the new sample is this picture. So we take these records and we move this record to be included into the sample. As well as we have shown, at each new sampling iteration, the already sampled records are left outside the set of possible samples to be extracted. The second type of simple random sampling is the simple random sampling with replacement. In this case, each selected record is not removed from the dataset, and so each record can be selected more than once. Also in this case, to show how the simple random sampling with replacement works, we exploit the graphical representation. Assume that at the first iteration of the sampling scheme, this record has been selected. Then it is extracted from the dataset to form the first element of the sample. Now, before proceeding with the next iteration of the sampling scheme, so before to sample the second record, we take the record that has been sampled and we put it back to the dataset. Then we proceed to select a second record from the dataset. Assume that at the second iteration of the sampling scheme, the record selected to be extracted is again the record that was selected at the first iteration. So again we take this record, we extract it from the dataset and we add it to the sample that now contains two different instances of the same record of the dataset. It is worthwhile to mention that when samples are small compared to dataset size, the two sampling strategies, so the simple random sampling without replacement and with replacement, generate samples which are not much different. However, when the dataset consists of qualitative attributes such that the possible values they can take have highly different frequencies, then random sampling can fail to adequately represent those type of values which are less frequent. Let the following picture to represent the dataset we have to sample from. Furthermore, assume each man's icon is associated with the value of a qualitative attribute for a record of the dataset you have to analyze. Possible values for the qualitative attribute are red, purple or green. Because red, purple and green in the dataset have very different frequencies, namely 2 for red, 6 for purple and 12 for green, if we extract a sample from the dataset using the random sampling without replacement approach and the sample consists of 6 records, there is a high probability that we obtain a non-representative sample of the population. To show what can happen, we use the following graphical representation. We extract now 6 records from the dataset, and this is what can happen. In this sample, then, we have 6 records, but we have 3 that are purple and 3 that are green. We have no red records. So to summarize the situation, we have the following. We have 3 different values for the qualitative attribute, red, purple and green. and in the data set we have 10% of red, 30% of purple and 60% of green, while in the obtained sample we have 0% for red, 50% for purple and 50% for green. Therefore, we can conclude that this sample is a non-representative sample of the dataset that we are analyzing. And thus, now we are left with the following question. How can we cope with this problem? The answer to the previous question is offered by stratified sampling. Stratified sampling can be of two different types. It can be equal number, and in this case we select an equal number of records for each of the possible values of the qualitative attribute. Also in this case, to explain how it works, we use the following graphical representation. If equal number of stratified sampling is applied, then from this dataset we obtain the following sample, where 2 records are of the red color, 2 records are of the purple color and 2 records are of the green color. Stratified sampling can be also of proportional type, and to explain how proportional for stratified sampling works, we again exploit the graphical representation. First, we make the assumption that we form a sample consisting of 6 records, and then we analyze which is the distribution of the records in the dataset. In this case, we know that the qualitative attribute can take the value red, purple and green. And we also know that in the dataset we have 10% of red, 30% of purple and 60% of green. Now we know that our sample consists of 6 records, so we simply compute what is the expected number of records for each of the 3 possible values. So we multiply 6 by 0.1, by 0.3 and by 0.6, obtaining 0.6, 1.8, 3.4, that after rounding bring us to the following distribution of the records. 1 record for red, 2 records for purple and 3 records for green. So in this case, the formed sample will consist exactly of 2 records of purple, 1 record of red and 3 records of green. Once a sampling technique has been selected, it is still necessary to choose the sample size. In particular, larger sample size increase the probability that a sample will be representative, but they also eliminate much of the advantage of sampling. On the contrary, in the case of smaller sample size, patterns may be missed or erroneous patterns can be detected. We do not give further details here on determining the proper sample size, which in some cases can become a major issue.